Hello, everybody. Let us enjoy with a new subject. Look to the photo here. It is about something we need it in our daily life, like sun, heating, lamp, lighting. And this means energy relationship in chemical reaction, which is thermochemistry. This leads us to discuss what about the nature of energy and type of energy, how this changes in chemical reaction, thermochemistry, enthalpy. So if you look to this photo, I think all of us need light, all of us need heat. So energy means what? Capacity to work, right? Sometimes you ask your colleague, let us go and run. Say, I don't have capacity to work. Means I don't have energy. This is the same for chemical reactions. Some chemical reaction produce heat. Some chemical reactions need energy, need heat, for example. So this is what we will discuss together and what we try to understand different types of energy. It can be radiant energy, like sun give us energy. That's why they use it in solar energy. So countries have strong sun are lucky because they can store energy through solar energy. This is green life. Thermal energy, which means it is associated by random motion of atoms and molecules, like you do a reaction and it produces the heat. Chemical energy is the energy with the bonds of chemical substances. Nuclear energy, now it is science is double-edged weapon. It can be good for humanity and it can be also used bad for humanity, because this means that collection of neutrons and protons in the atom, this is global problem they are discussing, and they try to use it in peace way, right? Another is the potential energy, which means what is the position of the object. So if we discuss chemical reaction, it means we will discuss temperature, right? And temperature means thermostat to measure the temperature. Let us take an example. If you take this heat, it is thermal energy. It is two bodies that have different temperature. And this means temperature is measure of the thermal energy. However, thermal energy is not equal to temperature. If you have, let us say, container or something at 90 degree, and you would like to decrease it, what you will do? Yes, you will make a shower of water, then it will be decreased to 40. So it means that you need greater thermal energy. Therefore, temperature is average kinetic energy of the particles in a substance. The thermal energy measures the total kinetic energy of the particles in substance. And what you expect when greater motion of the atoms or the particles, the higher substances, temperature, and thermal energy. A substance of total thermal energy depends on, therefore, temperature, of course, number of atoms, and the physical state. We will take examples of that. What about when the physical state of snow and the temperature is kept the same, like what happened in Scandinavian country, in Russia, etc. When they have snow and temperature is still the same, the snow will be kept because of the physical state. So more atoms and higher temperature means thermal energy. In all conditions, if all conditions are the same, of course, gases will give most thermal energy. Like when you do reaction of bromides with sulfuric acid, you see brown fumes and the tube will become hot. So the gases are most thermal, followed by liquids and solids. And how we measure the temperature? Of course, by thermostat. This is most easy. This is the most common uses. And it depends on the particles gain the thermal energy and the move. As I usually say, when you discuss something, look to the picture and try to give the explanation by yourself. What is the thermochemistry? If you have such 3 bottles, this is heating, but the bottle is open. Heating, closed, but the bottle closed. Here is isolated. What do you expect? What will affect here? So it means that we are going to discuss such a system, how the specific parts of the universe effect is interest to this study. What do you expect of the first one when it is closed, but it is, you heat it, like you take container, put water for heating, and it is open. It will be boiled and evaporated, the water evaporated. And if you forgot it, it will be completely evaporated. You forget it more time, it will be even destroyed, right? So it means that you have here open system. It means you have 2 factors, which is mass and energy. What about if heating but closed? You will have 2 factors. You closed it, so 1 factor only, right? It means that you have only energy. What about if it is isolated? It will be no factors at all. It will be nothing, right? So now you can understand the system here. The system measured by water, when it is open, it means that exchange of both energy and mass. When it is closed, it means that you only have the energy. When it is open, when it is isolated system, like this case, it means that you will have nothing, right? So what about if you take this reaction again? Look to the reaction and then you can explain in your own way. Hydrogen plus oxygen give water and energy. It means the reaction produce energy. It gives energy to the surroundings, right? And I told you energy and surroundings have the relationship. So it means it is ectothermic. Why? Because it gives energy. So now you get the definition by yourself. Water gas can give water liquid by energy. What about if you take another opposite way? This is a reaction, but here is the energy. So the reaction cannot occur unless you give him energy. So it needs energy. Therefore, when it is need energy, or you have to supply it with the energy from surroundings. So the other one was give energy to the surroundings outside. But this, you have to give him energy from surroundings. Otherwise, the action will not be occur. It means it will be endothermic, right? Like, for example, if you have, for the countries have snow, if it continues same temperature, snow will not be melted. You have to get tractor in order to remove the snow. So how to remove the snow? It must give energy. It must be sun, right? So you must get sun in order to give them energy. So when the water solid, which is snow, will give water liquid. Another alternative, of course, if we add chemicals, right? The chemicals can dissolve, can give energy, will be substitute of the energy, right? But this is not eco-friendly. This will make pollution, of course, and also expensive, right? So you see how much lucky when you have not so much snow, right? So therefore, thermodynamics, what is the meaning? It is interconvention of heat and other kinds of energy. And the state function are properties that are determined by what? By the state of the system. like like the example I said about snow, regardless how that condition was achieved. Energy, pressure, volume, temperature. 4 important state functions for such equation, right? So the magnitude of a change in any state function depends only on what? Initial state and the final state. Like when there is a race for running, it depends on what? Start point and end point. It doesn't matter of the intermediate, right? Sometimes run faster, then slower, then faster. But what is the end? So start and end. Doesn't matter what is in between. This we can see here. So the equation, now you know it. Delta E is equal E final minus E initial. This is a change in energy. If you go look to this, now I give you second. What's the difference between blue and red? See, blue goes from initial here until the final here. Red go from initial here through different pathway, right? But it goes to the same final, right? So is there a difference here? Yes, there is a difference of the intermediate, but initial state and the final state is the same. So it doesn't matter what happened in the middle, right? I think it is clear now. So potential energy of hiker 1, for example, and the 2, blue and red, is the same. Even so, they look different in both ways. So you see, chemistry is really fun when you understand it. When you look to the figure and try to understand it first, it is the same of pressure, final minus initial, volume, final minus initial, temperature, final minus initial. This expression of energy, pressure, volume, and temperature. Now, look to this photo. It's nice picture. Is the first announcement about first law of thermodynamics. What it is, energy can be converted from one form to another form, but cannot be created or destroyed. Yeah, so this is the energy, cannot be. Like delta E system plus, I told you, energy depending on the surroundings. So delta E system is equal delta E surrounding, like when you have lighting, right? Propane, if you react it with oxygen, it gives carbon dioxide plus water. This exothermic chemical reaction, as I told you before, it means chemical energy lost by combustion. It means that it equal energy gained by surroundings. So system equal surrounding is 6.3. Another form of delta E system is equal Q plus W, right? Here is the sign for work and heat. Now I think you can do it by yourself. When work done by the system on surroundings, by system on surrounding means minus. What about by surroundings is positive. What about heat absorbed by system from surrounding positive? What about heat absorbed by surroundings from the system, which is endothermic? It means need energy. You have to give it energy. It means it's minus. But it's exothermic. It gives energy. It is positive, of course. So delta E is a change in internal energy of the system. And Q is the heat exchange between the system and surroundings. W, of course, is the work done on or by. Therefore, W equal minus B delta V when gas expands against a constant thermal temperature. Okay, again, nice one. What about if it is sample of nitrogen gas expands in volume. So it gives you volume 1.6 to 5.4 at constant temperature. What work done in joules? If the gas expands, number A against a vacuum, number B against constant pressure. So it gives you these factors. Now you put the equation, which we have discussed. Then you take delta V, which is 5.4 minus 1.6 to give 3.8 liter, right? And at pressure 0. So W will equal 0 multiplied by 3.8 equal 0 liter. Then you take the delta V, which is 5.4 minus 0.6, which is 3.8, right? At this time, at P 3.7, because it asked you two. One, it is against a vacuum, and one against constant pressure of 3.7. So this is the first one at 0, and this is the second one at 3.7. Now you can calculate it in the final, because you have all the factors. So please practice together about such example, and also work with more examples together to me, right? Then now you can see and expect what we are going to discuss, right? So this is enthalpy and the first law of thermodynamics. Can you explain this photo? Yes? Look here. What is the difference? Huh? Now you know. Delta E is equal Q plus W at constant pressure, right? So it means Q equal delta H and W, right? So this is a law about it, right? Then delta H equally. Now you can look to the next equation, and it is, can you explain this? Take a moment. What is the difference here? Look here. What's the difference? Think for a second. Right? This is water solid. In order to be water liquid, you must need heat absorbed by the system from surrounding. As I told you, sun, this will be delta H equals 6. What about in this case, methane and oxygen? Is the heat is absorbed? No, it given off by the system to the surrounding. So it's from surrounding. Sun goes to the snow in order to be melted. But this is the opposite way, because, and then you get carbon dioxide plus water liquid. So delta H is equal H product is minus H reactant. I think now is clear for you about such example about enthalpy, which is usually quantified by heat flow or out of. So either that or out of the system in a process that occur at constant pressure. So all this will be at constant pressure, right? So this is very good example. And here is H product will be more H reactant, but this will be the opposite way. That's why this more than 0 must be, otherwise no melting. Here it will be less than 0. Is delta H positive, negative, or positive? System absorbed heat? It means endothermic, as we said before. Right? Endothermic, because it needs energy from surrounding. Then it is endothermic, then it is more than 0. That's why you need 6.01 are absorbed for every 1 mole of that melts at 0 degrees centigrade and 1 atmospheric, right? That's why in such countries, when temperature goes to 0, it started to melt it automatically. So water solid will give you water liquid at delta H 6.1. This is the energy absorbed or needed in order to melt it. Here is the opposite way, because this is energy gives to the surrounding. What do you expect? It will be negative or positive. So systems gives off heat. It means it gives energy, it gives heat. Exothermic, it means it is less than zero. So here will be energy released. We are lucky. We get energy. Because the world need energy. Then they look for sources to give energy, right? And this is alternatives when they need gas or they need petrols for heating, right? You know, it is sometimes international problem also that the price of heating in cold winter, electricity is very expensive. Why? Because they need energy. If you find the sources for releasing energy, then the electricity bill will be decreased. So you see, chemistry is alive even when you need heating or energy, which is very important. So we are lucky in this reaction because methane, that's why many projects in order to produce methane. Why? Because methane could be converted to energy. So for every 1 mole of methane, we release 890 kg at 25 degree and 1 atmospheric. So this is very good example. And now you know how to solve the problems of economy. That's why science is important for humanity, because it can give you a very good life. You solve the problems by science. What about thermodynamic, thermochemical equations? Look to the reaction we have said before. Water solid give liquid and it needs this energy. And if you reverse the reaction, it will be minus. If you take it the opposite way, right? It will be from so solid to liquid, it means positive. It need such one. If it is liquid to solid, it will be minus. If you multiply both sides of the equation by a factor n, then delta H must change the same factor, right? This means that water solid will give liquid, so it will be 2 multiplied by the volumes, then it will give you the double. So the physical state, which we talked about it in the beginning of the lecture, is really very important for all reactions and products that must be specified in thermochemical reactions as we study such example. How much is the second question about phosphorus? If you have 266 grams of white phosphorus burns in air, then you put the equation first, and then you see the factors, and you put the amount in or and calculate it. Then you get at the final how much is needed. Now it is very much 6,000, 4,070. That's why first we need to find the relationship between moles and the kg, as we have seen from such examples when we need energy or when it release energy. And this is how it works when 1 mole of phosphorus will give you this amount. Then you apply the equation and you will get the final amount. Now you look to the next example. What is the difference? Look, take few seconds. What is the difference between such states? Step 1 and step 2. What's the difference? Here, sodium chloride, which we use in our daily life. Step 1, this is the energy. And this in the gas state. Now this is a step 2, the heat of hydration. When it is hydrated on sodium chloride, then you get sodium chloride in ions. So this is a solid state, and here is the liquid state. In step 1, here is the amount. In step 2, it will be minus. Here is positive, here it will be minus. What about heat of the solution? From here to here is 4 kg, right? So this is the enthalpy of solution. So it is the heat generated or absorbed when certain amount of solute dissolved in certain amount of solvent, like in this case, water. So it means that delta H will equal step 1, which is this amount, plus step 2, which is this amount. Then this will give you the 4 here. I think it is easy for you now. So please, when you look to such examples, don't read here. Don't read here. Look first to the diagram and then conclude the results. From this, I will end with a very good question, if you understand my lecture. Now we go to brainstorm. Look to this question. What substance could be used for melting ice, like the countries I have mentioned? What substance from here do you need? Look carefully. What about my question is the opposite way? What substance could be used for a cold bag? We need it, yes. Sometimes you need to send cold bag to another country. So you need a surrounding with a compound. So what we can use? With this, I will end the lecture. Please think about it. And before you know the answer, try to put, and we check with each other next time. Thank you very much for listening. And please contribute it with a mission that's hope good for humanity. Thank you very much for your kind attention. And I'm looking forward for your also constructive criticism. يا رب يكون علما نافعا لي وليكم ولكل حد يشارك فيه يا رب. Thank you very much.